Alright, so we're going live. Alright, so we're making some changes. We're starting to get a little more high tech here. So anyways, I've come up with an ethical hacking game, and there's a number of reasons why this is, and I'm going to talk about what it is, how it works, why we're doing this. So first and foremost, I teach cybersecurity, I teach ethical hacking, and I run a company called notiaSquad where we do open source code. We develop things like purple team security privacy technology, basically, is what we do. And that includes learning how to hack and learning why hacking skills help you have better privacy, things like that. And so we've come up with a game called Hide and Hunt. And the way this game works is you basically learn all of the core foundational things, and it's something that you can just play with open source technology, like literally right now, right after watching this video if you wanted. And I'll start the video by telling you how can you access this game to play for yourself, and then I'll just show you how the game works, how you can play it. Basically, you can just kind of follow this video to learn what's called lateral movement, some cryptography, how to basically access different hosts remotely, like all kinds of crazy stuff. So let's just get right into it. So let's see. So I have all these screens. So this thing that you're seeing in the background, this is a platform I've been working on, and this interface is called Portainer, but there's a little bit going on under the hood that makes Portainer rather interesting. Now, there's a tool called Docker, so if you ever go to a website called, I'll just say docker.com, if you just go to docker.com, you'll find that this is a technology that you can download. It's a piece of software, and this software basically lets you create little tiny computers. And if you've ever heard of a virtual machine, it's kind of like creating little virtual machines. If you haven't heard of a virtual machine, it's like basically creating software computers, creating little computers out of software. So this tool called Portainer with this other tool called Docker, if you use them together, then they make for a very good home lab. And if you're trying to just do software engineering, or if you're just trying to do some home security development for who knows what, this tool called Docker is great. And what I just clicked on is it has these things called containers. For anyone who's ever heard of containerization, containerization is basically containing processes in their own little unit, so that you say, if we have a computer and we want to use that computer's command line, then all computers have a command prompter, and if we go all the way back to basic computers, even Windows has a command prompter, and I can access the command prompter of these little, or I guess the terminal is what it's called with Linux, with these little computing units. So if you've ever seen a virtual machine, or you've ever heard of cybersecurity and coding and all these things, then you see the black screens, people typing code, all that good stuff. This is called a bash shell. For anyone who's new to this stuff, anyone who's been using Linux for a while already knows what's up, what's going on. But Docker basically lets you learn how to create little software versions of computers, basically, that you can connect back and forth to, and you can set these up to basically hack them. So you can make little, and so I've made games with this tool that allow you to learn how to build all of the skills, so that you can, know the things that you need to know if you really wanted an actual cybersecurity job, or if you just think this stuff's fun and you just want to know how technology works, then that's just pretty sweet too. So if you want to know more about how to actually set this stuff up, on our website, I have a website called notiaSquad.com. If you go to notiaSquad.com, I actually have a guide where it says DIY engineers here for DIY engineers. If you click on this, there's a whole guide for this thing called the Olympiad. And right now we've only built what's called a threat intelligence engine, and that threat intelligence engine is called the Inner Athena. But we built this game called Hide and Hunt from the Inner Athena architecture. So in order to play this game, basically you need this, which walks you through installing Docker, basically on a Raspberry Pi, but really Docker works the same way on anything, so you can play this on anything. You can install this on anything. The only thing that might not work is you might need to use a Ubuntu Docker image. If anyone's curious about how to get this to work not on a Raspberry Pi, basically you can just message me like on LinkedIn or something along those lines. And if there's enough curiosity, maybe I'll make a video on how to basically build our Olympiad without a Raspberry Pi, but this technology is built for Raspberry Pi. But anyways, our website, notiaPoint.com, there's a little guide here. If you just walk through it with something like a Raspberry Pi, then you can basically play this game. Or if you have a virtual machine with Docker installed, or just Docker installed on anything. So let's just start getting into what this game is and how this game works. So this tool called Portainer that I was talking about, the thing about it is, if I wanted to set something up, and let's say that I were an instructor and I wanted to, or not just an instructor, or a facilitator or a dealer, however you have you, and I want to set up something for a group of folks to basically hack together. And you can have as many people as you can get running on whatever system you're using. In this case, I'm using a Raspberry Pi here. And for the most part, I've found that 10 people using one Raspberry Pi, you can basically access Portainer to access these little code terminals on these little containers from any browser. So you get one Raspberry Pi, install Docker, install Portainer, and then access it through a browser. As you can see right here, that you just punch in the browser URL, and as the person who's setting the game up, the way that it works is this little list right here is just a list of little computers that, as an admin, that guide teaches you how to create these. Basically, you walk through that little Olympiad guide. The Olympiad guide has you create this inner DNS control, which is something called a pi hole, and then it has all of these little Athenas, Athena 0, Athena 1, Athena 2, all this good stuff. So as the admin, the way that this works is you want to create these little Athenas, and each one of these basically gives access. This is just access for a little terminal computer, like a little software computer for people to access. And say that you want to have, in this case, I have Athena 0, 1, 2, 3, 4. Let's say that we had 4 people who wanted to play, and then someone's got to be an admin. So there are 5 people. We could set up a little game here. Let's say I were the admin, then I'd set up this little container here that basically lets me facilitate the game. And then I would set up these little, Athena 1, Athena 2, for different users, and go and you can create different users. So I created a user for Athena 3, Athena 4 to kind of show you how this works. So the first step of playing this game, Hide and Hunt, is that you pretty much just want to get all of the users set up, and you just want to get it to where players can play the game. And then I'll talk a little bit about the game, and then I'll walk through the game and how it works. So we'll go ahead and do a Jamboard session for how you play the game real quick. But just know that the admin sets up all these little things, and these little things create access for the players. And if we go over here and let's see, let me get a whiteboard that we can use real quick. So if we were to kind of chart out how this game works, and this game is called Hide and Hunt. So the way this game works is the first thing that you have to do is generally, admin must build infrastructure, so you got to have an admin. And the admin uses the Olympiad white paper guide that's on our website, notiaPoint.com, follows that, and then if you follow the guide, those containers that say Athena, Athena 0, Athena 1, so on and so forth, those are basically what the admin has to set up. And then the admin sets up user access, all that good stuff. Now, the next thing that has to happen is so user access must be set up and provided to players. So there are a number of things that make this game a very educational game, because whoever is doing the admin work, like that, I mean, that's cybersecurity skills all by itself. That's architect work right there. So if you can be a person who knows how to architect this game, I mean, that's a job in the real world, is being able to architect things. So bam, there you go, real world skills. And then setting up the access for people, now you've basically coded yourself a little game that you can play with friends. And now you can teach your friends like hacking skills and cybersecurity skills, which the next part is not quite as technical as knowing how to build. So this is a great game for like educators and instructors, where the admin might be an educator, might be an instructor, or if you're just a person who likes to host things and you want to host something that's kind of like hacking related, that's pretty fun and neat to do, or you know, maybe like fun company events, things like that. So user must set up, and access must be provided to players. After that, players will learn about SSH. If they already know what SSH is, then basically they'll just see what it looks like to install it. For someone who's never touched Linux before, this is a great little lesson. Learn how to install this thing called SSH, learn what SSH is, learn how to access back and forth with it, and basically this is where we start to get into lateral movement. And then the next thing is so we teach you basic lateral movement with SSH. So you'll learn a little cryptography with SSH too, how to build SSH keys basically. And then there's going to be a little bit of learning how to basically steal what are called public keys. So there's a couple of lessons that come in here. So a few lessons that you'll learn. So you'll learn some painfully basic cryptography, just out of the nature of how this game works. And then in terms of lateral movement, that, you know, that's a little different. That is also going to teach you some basic reconnaissance. I'll just say recon for now, that's good enough. So you'll learn some general cryptography, some general recon. How exciting. And then finally you'll learn well, I probably spelled that wrong, but either way, exfiltration. Players must learn exfiltration and data mining basics. And the way that this works is basically players are going to learn how to hunt for things that the other players set up, and then basically steal data from each other's systems. So it's this is where it becomes a little bit of a CTF, and basically whoever executes capturing the little flags, I guess it's kind of a CTF, Uh, I'll just say like almost like a CTF. It's not really a CTF if I'm honest. Almost like a CTF. This is actually more real world than a CTF. So it's almost like a CTF, but this is with real stuff. Real keys, real things, real stuff, real stuff. So that's something that you want to keep in mind. So anyways, that's like the high level, like what's this game? How does it generally work? Admin sets stuff up, gives access to players. Players are going to learn some basic SSH. Players will then have to learn some general recon, and then finally players are going to have to learn some basic data mining, which is great. So let's say that we've gotten all the way to where an admin has provided logins and someone is ready to go. Last thing that an admin has access to is you can actually watch the players, and you can use this tool called Pi-hole. Pi-hole can be used in a lot of ways, but in this case, because of how DNS works, you can see people kind of accessing back and forth to the different systems this way using Pi-hole. There's a little more that goes to that. So once again, if anyone's curious about how you can monitor people playing the game using Pi-hole as an admin, while people are playing, you can just kind of at least watch the activity, see what it looks like, watch what it looks like when people are hacking each other. So if you use the Olympiad's architecture, it has you set this unique Pi-hole up. You can see that this has 6 things connected to it, which happen to be containers here. So we have 1, 2, 3, 4, 5, 6 right there. This portainer item is not connected to the Pi-hole, but all of these items are connected to this Pi-hole that lives inside of a Docker container. And learning how to network this is another thing that is just a lesson and a half for anyone just wanting to learn. So just being an admin alone and facilitating something like this is an educational experience for those who want to learn the real stuff. Be an admin. Now, let's get down to the user experience. How do you play the game, and what do the users see? So if we go, I already have a few users logged in. I had created a user account for an Athena 4 and Athena 3, as you can see right here. I've got these logged in. And the neat thing about this portainer tool is if I click on these and go over to containers, you clearly saw that the container list was much longer on the admin list. Well, you can't really see the right side because my big head is blocking it. But here we go. So this thing, you can just give people logins, and the best part about this is that imagine each one of these browsers. Anyone who has a browser can just connect to the system that this is all networked to. So whether you have this Docker engine set up in AWS, in a VM in AWS, or maybe you have this whole ecosystem set up on a Raspberry Pi VM locally, not in AWS, it really doesn't matter where you have Docker installed. As long as you have Docker installed and then you install Portainer, you can set this up so that you can create like player access so folks can learn how to hack each other. And it's just such an easy thing. Once it's set up, it just works, and then bam, you can just keep teaching folks this stuff. And it's cheaper than VM. Like if you wanted to have a bunch of AWS VMs and try to teach people this stuff, VMs get expensive because for every VM you spin up, you have to pay for that. But if you go to AWS and buy one VM, install Docker Engine, then instead of having say like a VM for every player, then you can create these little containers for every player instead, making Docker great and containers better than virtual machines for education, in my personal opinion. And let's start playing a game. So if we want to play this game, first players need to know how to access their systems. So the admin should show players how to access their systems, which is if they, when they first log in, the first thing that they see is this little thing. Have them click on that and click on where it says container, and then they get this listing here that shows what they have access to. And if they click on this exec console thing, these containers have a username, so it's even though they can just start off logging in root, there's a number of things that are worth learning. One of the first things that users should learn is how privilege escalation works. So you type in the username by default, if you use the Olympiad documentation, is Notitia, notitia, and this means data in Latin. So we're going to connect to this. So notitia means data in Latin. And now that we are logged in here, notice it's this little symbol here that gets to this terminal. So you see the terminal on the left here. If I go and do this on the one on the right and hover the mouse over this little quick actions exec console, that's what gets us into the terminal. So we click on that thing, and then under user, once again, if you use the Olympiad guide, then it's just Notitia, and you connect, and voila, we are officially connected to these little systems. So something that is rather important to understand when players first set up is that the first thing that players are going to do, and we're just going to walk through the game hide and hunt, and if you're going to do the lesson, you can actually just follow this, and bam, here's your lesson right here. It's recorded. You can just kind of watch this thing and then just mock this whole thing, and voila, you have a really cool class to teach folks. And then with Raspberry Pis or VMs, if you build this in a VM, then it's just always bam, there's your educational VM to teach folks this stuff whenever you want to spin it up, or bam, put it on a Raspberry Pi. Just bring that Raspberry Pi with you, and then just make sure that people can access it and they can play this game. So, and we do our code all open source so that folks can basically just do this stuff. Okay, so the first thing that anyone needs to do is just, on the Athena 0 node, this one says Athena 4, but by default these don't have SSH installed on them, just because the admin node should not have SSH installed. But if this is not an admin node and this is a player node, then when the players begin, the first thing players should do is they should learn how to install SSH. And for people who've never used Linux before, this is great. They type sudo apt install SSH. For anyone who's installed things in Linux before, this isn't that new and it's not that exciting. But if you've never installed anything in Linux, this is how you install something: is you type sudo. Well, sudo means super user do, and then the install command is really apt install. Now, notice that this is asking for a login. This container, if you followed the Olympiad guide, one thing that I will do to make this slightly less confusing here is if I go and open a tab and say Docker Hub, if you followed the Olympiad guide, it had you go to Docker Hub and it had you grab this Notia Point Inner Athena guide right here that's hanging out. And this Inner Athena guide also has guidance on how to install, but most importantly, once again, this is in that Olympiad guide, so I'll show you how to find this, but default password right here is, let's put it so you can see it on the screen. It's a little hard to see it. Let me try to get that a little better to see. Okay, so notice we can see the login information here. Default username notitia, and default password this. Let's just type it in. So that's going to make sure that SSH gets installed. Now, if anyone's wondering, how did I even know to go find that password? How do I, like, if you're the admin, then you would have found this when you were on the website. So you go to notiapoint.com. If you had done what I recommended and gone to the website where it says the Olympiad, this guide right here, it's just part of the guide. It's actually right here. I can click on it. That's how I found that. And it has just information on these little systems here. And that's what these little Athenas are. So if there's any confusion there, I'm just going to clear up that confusion. But anyway, so the first thing that anyone should do is install SSH. And so you get to see me do it twice, which is helpful. And so this is what both players do. They set up SSH first. as soon as they have SSH installed, then people should know how to manage services. So there's a lesson here. So all of this is basically a great big learning lesson along the way. So now anyone who doesn't know how to manage services, the next thing is we learn how to do. Got to learn how to make sure that the service is started and running. So we type in this command sudo service SSH start, and then sudo SSH enable. Hold on, sudo service. There we go. So we want to run these two commands. This basically makes, like, anytime you restart this little container, then SSH will basically start running. And then we also want to know, like, some other service commands. So sudo service SSH status, and we can run that, and we can see that it shows SSH status is running. Now, to avoid boring you, I already did that on this one. So if I type sudo, you don't even have to type sudo, I don't think. Then, you know, SSH is running on these. So everyone needs to make sure that if they run status, they're going to make sure that SSH is running. So that's the first and most important thing here. Now, just looking at this, the next thing that a player is going to need to do, because this is a lot of information here, is you're going to want to generate. So this is where we learn a little bit of cryptography, not a whole lot, but we're going to generate what's called an SSH cryptography key, and you do that by typing SSH-key gen, and you hit enter, and this will generate a public/private RSA key pair is what that's called. Now, for what we're doing in this game, the most cryptography we're going to teach is just how to generate a key, and so you can see what it looks like, and kind of talk about the concept of what's called a PKI, which stands for public-private key infrastructure. That's called a PKI, so we're going to learn what a PKI is. But when you run this command, just hit enter a bunch of times to everything. It says a whole bunch of things, but you just want to do that. And so here's part of the lesson here. So that we want to have a general understanding of privilege escalation. And notice when players first do this, they're going to run into a scenario where you get this command that says no such file or directory. And when, say, user accounts don't have certain accesses, this is where the user is going to have to basically learn how to elevate their privileges. And so to show like how to get around something like this when you're generating something that's like a sensitive type of file, like a key, then what we can do is we type this. We type, let's see here. You can do different things, but I'm going to type sudo and then su. And this is just going to teach people what this command is, what it looks like. And if you hit enter sudo su, notice it changes where it says notitia here. It changes this to say root. Now, of course, we're just learning. I'm not teaching anyone how to be like a professional admin. We're doing a game here to learn different elements of networking. So what this is going to do is this is going to elevate permissions so that when we go back and type this command, which I'll just type it again, SSH key gen, and hit enter, then this time when we go and hit enter a bunch of times, it's going to do this thing, and this random art image is a confirmation that we've generated a key. And notice that now if you're the admin and you're helping people play the game, you might have to help people kind of understand navigation here. You might even have to do a lesson on Linux navigation, how to navigate Linux, what a file directory is here. And if you're watching this and you don't know how file directories work with Linux, that might be something to look at. But for if this is something that educators are the admin of, then you're there to facilitate, and you can make sure if someone's confused and they're looking at this and it says your public key has been saved in, it's very important to now know where the public key has been saved, because everything we're doing, we're going to move the public key locally, and we're going to learn how to move files around. We're going to learn how to create public-private key infrastructure, and then we're going to learn how to move this key into that public-private key infrastructure. That's how this is going to work. So I need to do the same thing for both. So we're just going to say sudo su on the other one, and we're going to run that, generating public-private key, and we're going to just hit enter again. All the exciting things in the world. So now we have these keys. Now Linux lets us navigate, and if we type cd, we can navigate to where this public key is, because this public key is something we care about right now. So we can type cd space root okay, so we can just navigate to that directory and type ls space -a, and for anyone who wants to, nice thing about videos is you can pause it and see what I'm typing, things like that. And we can see right here that the key we created, this id rsa pub, it lives in this directory, just kind of hanging out, chilling, doing its thing. That's pretty cool, right? So cool. Yay. It's the most exciting thing. Okay, so we have a key, and both of these now have a key. So the next thing that we're going to have to do is we need to create what's called PKI. So this is where the game becomes hide and hunt. We are now going to hide these keys, and then once all of the players have hidden their keys, then all the players must learn how to go connect to the other person's system and try to find where they put their key. And so if you're playing this with people like for educational purposes, and it's just like a lesson, and you're not trying to do competitions, and you're not trying to make too much of a game of it, then just doing one round of this is plenty. And if you're doing one round of this, when we hide these keys, there's a certain way that I'm going to recommend hiding these keys. But for some of you who are a little more competitive, there are two ways to play this game. One, you're educating, you just want to get through the lesson, run through the whole thing, show people how it works, bam, they learned lateral movement, the basics, great, they know how to do some stuff now, cool. Two, you want to make a competition of it. You want to get all serious and do extra things. If you want to make a competition of this, then you get a whole bunch of people connected, and you do multiple rounds. You do like 3 rounds or more, however many rounds you want to do. And the way that the rounds work is the first round. Let me talk about this PKI. So PKI. Let's do that. So what is a PKI? Let me just write that down somewhere so that that's not too confusing of me to talk about. So let's just talk about what a PKI is, because we need to do this. So a minor interruption. PKI equals public key, public-private key infrastructure. Now, PKI means a couple of things. So a PKI, let's see, PKI could be an entire server if it's a server that has, it's just a server designed for managing keys, and that's all its purposes. And alternatively, it could just be like a file directory. But one way or another, the key infrastructure is just whatever keys are organized in. Our keys, cryptography keys is what we're talking about. Our cryptography keys, and we need cryptography keys for access. So I'll just write that down too. It's a little more complicated than this, but if I just dumb down what cryptography keys are to just like a real basic blanket statement, cryptography keys allow systems to get access to other systems and so on and so forth. So we generated some cryptography keys. So cryptography keys, you know, they add security and things. And then normally, you know, if you're working at a company, you should know how to create cryptography keys and then organize them. That's like a basic architect skill to have. You want to know how to create cryptography keys and then organize them. Well, we created cryptography keys. Now we need to know how to organize those cryptography keys into PKIs. That's going to be very important here. So let's do it. To do that, we are first going to we're going to hide our PKIs, because the whole idea of a PKI is that you want it to be obscure anyways. You don't want to just leave your keys in the default location. If we just left our cryptography keys, because if cryptography keys are designed to give people access to things, then if we want to make sure that, like, if we get a pen test or a hacker gets in our environment, something along those lines, we just want to make sure that we have some security. So that's what that. So we want to make the keys not in their original location. So let's do this. So first we have to choose where we want to put these keys. So in Linux, if you type ls space -a, we get to see what kind of things we have. So if I type cd space ... and hit enter, that goes backwards in directories. So I'm just going to go all the way to the root of Linux. So if we just go all the way to Linux's root and do ls space -a, where we have, you know, etc, boot, dev, bin, all those things, var, all that good stuff. Once we get here, for the first round of this, or if you're just teaching to just do one lesson, make your PKI not too terribly hard to find for the first go around. And tell everyone, like, don't make your PKIs too hard to find. And so what we're going to do to make this manageable for the first go around is hide your PKI folder. We're going to create a folder to put the keys in. We're gonna create this folder inside of one of these folders here, where my mouse is pointing. So I'm going to go ahead and for now choose. You can see one I created right here. What we're going to do is we're going to very specifically name our PKI after an animal. Let me put that on the whiteboard, just in case anyone was, because that's kind of a hard thing to. So there's a reason for this. We're going to create a PKI folder, and we're going to name it after an animal. The reason why we're going to name it after an animal, actually, I just want to make it blue. The reason why we're going to name our PKI after an animal is to make it a little more tricky for folks to figure out, and also easier for people to figure out what they're looking for. So this will make a little more sense, but this is actually really important. You can choose something other than an animal, but you want to have like a theme, because then when people hide their PKI folders, you know, you could name it like Mongoose. If you made a PKI folder named Mongoose, then when the game starts and people hack each other and do the lateral movement piece, then they know that they're looking for a directory with an animal name, and it makes it a little easier to. And you can change that up if you want, of course, but I'm just going to standardize it and just say, for the base of the game, just make something named after an animal. So we're gonna do that. Let's do it. So we're gonna say, to create a directory, we're going to build it in the OPT directory. And so players all need to build in a location where they, you know, they want to make the other players have to hunt, you know. So I'm going to say cd opt, and I'm going to, for this player, the Athena 4 player, we're going to say mkdir, and we're going to create a directory that says mongoose, because that's what I said, mongoose. And if I type ls space dash a, then we can see that the directory mongoose has been created. And then we are going to do something similar over here, where we are going to go back to the root. And in this one, we're going to hide in something different. We're going to say cd sys ls space dash a. So we're going to make our directory here for Athena 3 mkdir duck. Doesn't really matter what the name of it is, but oh, actually the system directory you can't build things in. There's also another reason why this is a good lesson, because you'll see that some directories are like read-only and so on and so forth, and you can learn what the default permissions are on directories. So players will learn like, oh, I can't create my PKI here, my PKI directory here. So let's say let's go back cd ... So let's try to build the PKI directory. Let's do it in etc. So we'll say cd etc, and then we'll say mkdir duck. Oh, mercy be. Okay, so as you can see, it's much easier if someone were to go into the OPT directory and then they just see mongoose. It's right there. But I just created this duck directory and I hid it here in the etc directory. Someone has to go look through all this, and there it is, duck hiding. So these are some things that players will learn about as they're doing stuff. So players will have to figure out, like, where am I going to try to hide this? And for round one, just hide one layer deep. Don't hide more than one layer deep for the first round, because also you run the risk of like some players take longer than others, and so you might have one person who finishes the game like right away, and then you have like another person who takes like 30 minutes longer or 50 minutes longer. So we now have our directories, and now we need to move our keys into our directories. So this is the next step here. So to move our keys, we can use this command here that says, and actually I'm just going to navigate to these directories. So I'm going to say cd mongoose, and then here we're going to say cd. Not that it matters, but anyways. Now that we have created a PKI, we have to move the keys into the directory. So to move the keys into the directory, we can basically use the mv command, and then everything starts in root.ssh, and we just want to move all the keys, so type it like this. So this is the command for like move the keys from root and then the directory.ssh, and then say move everything in there. That's what that star means. And then we have to choose where we want it to go. So we are moving our keys into OPT. So see, that's that directory that we just created. So we're gonna do that, and then we can just double check that everything's there. So ls space dash a, voila, there it is, and then we can just type it again, mv. And then so then we should have the same situation here, and voila, exciting. Apparently there's another file in here for known hosts, but that doesn't really matter. So okay, now that we have our keys moved, it's time to start to learn the lateral movement piece. And that's going to start with, okay, so when players do this, players don't yet know where the other systems are. So it's this little node right here has Nmap installed on it. So then we can just type Nmap, and if you followed the guide and you built this on the guide, then this IP, you can use this exact command that I'm using, because this whole thing's built on a very specific network, and it'll just work. So I'm going to just say nmap IP address 1 through And for the sake of time, I'm just going to say 5 because there's not that many systems on this running. So we're just going to say 1 through 5, nmap IP address dot 1 through 5. And then we're just going to run that, and I'll do the same on both just because. And then let's get a little music here while we're waiting for this, because this is you know, we're waiting. It's doing something. So this is what. This is actually normal. Nmap, the reason why I set it to 1 through 5 is Nmap scans can take a little bit of time, but this is just a nice little thing for folks to get an idea of what Nmap is, how Nmap works, and when you get to the point where people run Nmap, it can be worth just, you know, maybe taking a break or something like that. We're giving folks a little bit of a moment. But it shouldn't take longer than like 5 minutes or so. Let's see. I actually want you to see these results. So I'm gonna wait a little bit. I guess with this being live, it's like one of those things. So I guess I can just talk about a few things to add a little context while we're waiting for this and kind of talk about what to expect next, just because why not, instead of just having this sitting here. Let me adjust some things while we wait, and then I'll talk about that. Okay, so let's see. So what I'll talk about while we're waiting on this. The next thing that's going to happen basically is this Nmap scan. It's going to show us the information that people would need to essentially infiltrate another system. And then these systems are basically going to use this SSH tool that we installed, and then that SSH tool is going to let them start to look at each other's data and try to find that directory. And you'll see it's overall that portion of it's a little more straightforward because of the nature of this demo. You know, I might actually do something to speed this up, because I also know I'll let this one on the right keep running, and then I'll just kind of show you the rest of the game, and then we can yeah, let's just do that. So if you hold Control and hit C, that'll cancel what's going on. But these scans are the same. So since we're running 2 of these anyways, I can just let this one on the right show what the Nmap results look like. But basically, it shows just the IP information. Something else that someone can do, oh, there it goes, to see what the IP address of the system that they're on is they can type the command IP space A. Now, IP addresses are basically like the ID codes of a system. If you've done anything on a network, you've probably dealt with IP addresses before. But we can see right here that this has an IP address of 05, basically, dot 5. This is the IP address. And the scan that we ran, it shows a number of things. It shows that we have this inner Athena scan right here. And so that's Athena 0, Athena 1, and then we have Athena 4 and Athena 3. Interesting. I wonder. So, and notice one of these isn't showing up. Let's see it. 0, 1, 3, 4. Notice that Athena 2 is not showing up because it's actually on a different network. So Nmap basically just shows you like what's on the network. And then notice that we can see SSH on these. And so if this is Athena 3 right here, well, actually, we can see Athena 4 on this one. My camera's blocking where it says Athena 3, but we can see that I'm on Athena 4 here. The other one's Athena 3, but we can see clearly that, okay, look, SSH is available. Now, if I were to uninstall SSH, that would mean that this hack does not work. And oddly enough, a lot of companies get breached via SSH. I've worked on some huge threat cases where SSH was the thing that caused a company to be breached because they didn't understand how to secure SSH. So anyways, once someone finds the IP address of another system, I typed this IPA command, and I see that we're on 172.20.05, and then we can see over here the IP address. And so, alternatively, Athena 4, we want to target Athena 3, which is at this IP address right here, which is this 172.20.04. All right. So let's learn how to actually start to hunt. So to hunt, we type SSH, and then we, let's see. We can type notitia at 172, basically the IP address of the other host that we want to attack, basically. 0.4. So that one is 4 because that's the one that we want to attack. We want to attack Athena 3. So when I hit enter, notice it gives us a little key that it says that's going, all this stuff. Just type yes, and then the password is going to be that notia point exclamation mark 1 sort of a thing. And notice here where this changed from Athena 4. Notice that this now says Athena 3. This is important. That lets us know that we are now actually in the other system. There are other things you can do to kind of see like who's actually monitoring your system. So, I mean, if anyone was just like dreadfully curious and wanted to see what that looked like when someone's like attacking them, they can do things. Well, I won't get too far into the weeds. I'll show that later. But anyways, you can actually like monitor people getting into your system. But continuing on with the game, we've broken in. Now we want to figure out where we can find that folder called duck, and it's been hidden in here. So we have notitia Athena 3. We already know that it's in CD and then etc in this directory. So if I go here, then lo and behold, we have the directory duck. So if I type cd and then duck and hit enter here, then bam, I've just found this other system's stuff. I just found it, right? And it's right here. Bam. So now, of course, if you're playing the game with a bunch of people can play. You can have someone on their cell phone, someone on a tablet, someone on their computer. As long as it can use a browser, they can participate. Is how this game works. But now it's like, okay, great. Now we found the data, and we found these keys. We found these access keys, basically, and we're gonna steal these keys, basically. You could think of cryptography keys just like kind of like a car key or a house key. They kind of work that way, and so we're gonna steal them. So to steal the keys, once you find them, we want to basically steal their entire PKI, which is that public key infrastructure. And this is also how we know, you know, did you actually? Why do we have to name it after animals and things like that? I'll show you. So now that we know where the file is, we can get out of here. So we can just simply type exit, because the goal is you find the directory. Great. As soon as you find it, you just hit exit, and that brings you back to your node that you were in, your little container. And let's see. This is a lot. This is a lot to memorize, and just a lot of information too. Okay, we've exited the other system. We know exactly where the directory is, and the nice thing about it is notice that it also keeps the path so that we don't have to try to memorize where that directory is. It's sitting here, and even as we scroll, we can like scroll back up to see like, oh yeah, where was that directory located again? Not a big deal. Now it's at least like on our screen, and we are going to pull those keys over. So the first thing we're going to do is actually we're going to go to our directory. So Mongoose, I'm already in there, and then we're going to make the directory for their PKI. We're going to just recreate their PKI. We're going to say mkdir duck. And then other people will be able to go and validate that you indeed found their PKI this way. Because the only way that like you would know to create a PKI called duck to put their stuff in, you can't fake this because you had to go and find out what they actually called it. Because that is a name of an animal. Okay, great. Now you have to go find a folder with an animal name. And then once you find it, exit their system and then recreate that PKI. And then if, let's say that there's more players, let's say that you found there was another player and their PKI was dog. And then maybe one was so now notice if we had more players, let's say that there are 4 people playing, and if there are 4 people playing, and then let's say I made Mongoose, then after I find everyone's system, then I can clearly see like, okay, so whose systems did I find? And then whoever finds everyone else's systems first is the winner, and then they can basically help everyone else get through it. So, but we haven't stolen the keys yet. All we've done so far, because if we go over to cd duck and hit enter and type ls space a, we still don't have the keys. So that's now we have a problem. And really we only need the public key. So we're going to learn how to steal a public key here. And that's the last part of the game. And then as soon as you've stolen all the public keys from everyone else, then you're done. And whoever does it the fastest is the winner. And then whoever wins, then it's their job to help everyone else. And along the way, let me finish doing this. Let's just finish the game here. So let's steal this. Let's steal this data. So we are going to type a command scp, which is dependent on SSH, and we're going to say notitia at Athena 3. So we're going to say we want to take everything, and really we're just going to get the public key because that's what we want, and then we're going to say oh, I gotta write the whole path. So that's going to be opt. So we want to move this straight into the other directory. So this scp command, we're saying that, okay, great, I'm going to use SSH to grab everything from the directory here. And actually, I need to make sure, you have to make sure you type the whole directory right. Because that was living in etc. So you want to make sure that you type the directories right. And then we're going to hit enter, and it's saying some things. So we're going to say yes, and we're going to hit enter, and then it says some other things, and then I got to type in the password. And there we go. And the thing that we want is the public key. So now we are in the duck directory. As you can see there, ls-a, and there we go. Now we officially have what we came here for. The point of this is to learn how to steal keys. Learn how to create keys, learn how to steal keys. For real. The real world stuff. And we've done it. Yay. So this would, now let's say like this would be the winner. This player now has won. And this player over here is behind, so then this player can now help this player out. And a cool thing to go with that is the other player can come over here and take a look at kind of the general activity in the Pi-hole. So if we click on this query log, I don't know how long I feel like digging into this, but you can actually do other things to make it easier to dig through this. Oh, here we go. We can see a little bit of the activity here on the top clients list, so we can at least see like where the general activity is. We can see that there's more activity on the Athena 0 node and Athena 1 node, and we can see that there's more requests to the Athena or from the Athena 3 node, which makes sense because that's the one that I was running more commands on, and fewer requests from the Athena 4 node. And so you can see, you know, which nodes are getting accessed the most. And you can set up a Pi-hole just for this. This Pi-hole has some extra data that kind of makes it a little messy and makes it not quite as clean. But Pi-hole is just a really convenient way to just kind of get some basic monitoring for the admin to watch the game, and then also some monitoring for the people who win to watch the game while they're waiting for everyone to do all this. Some other pretty neat little things that admins can do is admins can... admins can... Let's see. Well, they can monitor the systems too. So if I go over to Athena 3 and I click on this little thing, I can take a look at the processes running. I can see what's going on with all this stuff. I can see, with this I can see who's connecting to things, because we can see that we have root connecting here, we have Pi connecting here. Just different things. And then if we were to, let's say that we wanted to see who's connected to our system. Check this out. So this is just something that is just kind of interesting for anyone who wants to be able to, like, let's say that you completed the game and you just kind of want to like monitor your processes. If you're like waiting on other players to complete or whatever, you're just kind of curious. Because if you're waiting on other players, you can also sit and kind of see who comes into your system. So you can do this and say sudo apt install htop, and you can install that in a little Docker container. Actually, let me run it. Actually, I can just move my face. I'll move my face over. Move my face. All right, so then we can just type htop. That's pretty neat. And in htop, we can see who's connected here. I'm going to type SSH. And you can, instead of typing the IP address, you can type like Athena 3. You can just type the name of these hosts too. It's set up this way. So we can say SSH did it. Okay. There we go. And here we go. Bam. Haha. That's it. We can see people coming into our system. Kind of neat. And so like this just starts to go into monitoring. So, you know, if you're a winner and you're just kind of watching folks, you can go ahead and just, you know, install htop if you want. If there's no internet access on these, I guess that's not going to be an option. Well, then you won't be able to install SSH, so these do need to be network connectable unless you like pre-install everything, which an admin could pre-install everything if there's not going to be network activity or network access. Because really, if you're using a Raspberry Pi, everyone could literally just have a Raspberry Pi, set up the Raspberry Pi as an access point, have everyone's cell phones connect to the Raspberry Pi, and everyone can play this on their cell phones. That's just one of many ways to play this. Just like an easy way to learn stuff. I could come over here and type various things. Let's see if there's a command I could come up that might be interesting. So I could type a sudo apt update and run that, and then we should see the update pop up here. Yeah, look at that. That's kind of neat. So we can see people running commands, and so like this shows you what it's like to do lateral movement. This shows you what it's like to watch people jumping into your systems. I mean, it's just how it works. It's the stuff: networking, hacking, doing the things, moving seamlessly across systems back and forth like a pro, you know. And that's it. That is the game Hack and Hunt. So I hope everyone enjoyed that, and I hope it was interesting. And that is one of our first. This is not our first game. We have another game called Assault Grid. The problem with Assault Grid is that it really only plays well with if everyone has like their own Raspberry Pi, or if everyone has their own virtual machine, stuff like that. This game's much more accessible overall, so that's the game that I'm going to be sharing with folks right now, and I'll probably be helping folks do this stuff. So if you're an educator, or you're trying to teach people these things, or you're just trying to learn this stuff yourself, talk to me, reach out. I appreciate you. I appreciate you.